So let's go ahead and talk about z-tests with examples. I've got the first example where you have to enter the data, and the next example is where the information is given to you in the problem. So if you're doing a z-test where you have to enter the data into the calculator, the first thing you're going to want to do is go to stats and then enter your data. The data I'm using right now is on page 486, and it's about bench press scores. So I just went ahead, and I'll show you this and then I'll explain the problem. And I went ahead and I just put my data in. That's all I did. I put it in my L1. And then the next thing I'm going to do is I'm going to go over to stat, scroll over to test, and then hit enter for z-test. Because I have data, I'm going to click where the data is flashing and hit enter. And then I keep scrolling down and put my information in. The first thing under data is the population mean, and that will be given to you in the problem. The next is the population standard deviation. Again, that should be given to you in the problem because for a z-test, you have to have the population standard deviation. List is L1. Frequency is 1, and then you pick your alternative hypothesis, and then you hit calculate. Okay, so let's see what goes on next. And you get an output, and on the output screen, the first line is the alternative hypotheses. That is a great way to check yourself to see what you're doing right and what you're doing incorrect. So Z is the z-test statistic, P is your p-value, X bar is your sample mean, and N is your sample size. So let's go ahead and do an example. So a college football coach thought that his players could bench press a mean weight of 275 pounds. It is known that the standard deviation is 55 pounds. 3 of his players thought that the mean weight was more than that amount. They asked 30 of their teammates for the estimated maximum lift on a bench press exercise. The data ranged from 205 pounds to 385 pounds. The actual weights are below. So what they did is they put 3 players could bench press 205, 3 could bench press 215, and they wrote it that way as opposed to writing everything out. So you're asked to conduct a hypothesis test using a 2.5 level of significance to determine if the bench press mean is more than 275 pounds. Okay. So the first thing we need to do is this test a one mean or a proportion? Well, it talked about mean all through the problem. And if you go back to the problem, it actually says here, determine if the bench press mean is more than 275. So that means this problem is a one mean problem. Excuse me about that. And now it says state the null and the alternative hypotheses. Well, again, it said the mean is greater than 275 pounds. So I'm going to put in my alternative hypothesis, the mean is greater than 275 pounds. My null is the mean is equal to 275 pounds. So the reason I did that is it didn't tell me anything about less than. It just said, so I'm just going to put equals. So C, is this a right-tailed, left-tailed, or two-tailed test? This is a right-tailed test because it's a greater than symbol in the alternative hypotheses. Okay, what symbol represents the random variable for this test? And that is capitalized X bar. In other words, to find the random variable for this test, so capital X bar equals the mean weight in pounds lifted. That's what they're trying to determine. And then it asks, if this population standard deviation is known, and if so, what is it? It's 55 pounds. And I got that actually from right here in the problem. It is known that the standard deviation is 55 pounds. So I know what it is. So I'm going to keep going. So the next part, calculate the following. Sample mean, sample standard deviation, and N30. So let me show you how I can do that. So I've got my data in. Let me go here and I'll show you again. See, I've got all my data in, and I've got all 30 values. And when you do have to put data in like this, I would say check yourself to make sure. And a great way to see if you have everything is when you click on the last value, it'll say L1 parentheses 30. That means in L1, I have 30 values, and the last value is 385. That actually tells you how many data points you have in the data set. So then go to Stat, go over to Test, again, hit Enter. Now data's clicking, and I want it to click and to flash at me, and I'm going to hit Enter, and then I'm going to go down. And remember, my population standard deviation was 275. My population, this was my population mean of 275. And again, that's the mean that's found in the hypotheses. This right here, the sigma, is population standard deviation. And remember, the question the problem told me it was 55 pounds. And I have that back on the page before it that can help me. List is L1. I'm going to keep it that way. Frequency, I'm going to keep it. Now, this is for the alternative hypotheses. I need to go and I need to pick the right one that I picked on the page before it. So I'm going to go here and hit Enter. Okay, and let me show you right fast. Let me show you where I'm getting all this information from. Okay, so let's go over it again. Here's the data. Population mean, which you can see is in the hypotheses. Population standard deviation, which I wrote down right here. L1 is fine, frequency, and now it says pick which one. And I'm going to do this greater than because it's what's in the alternative. So I scroll down again and I hit calculate. And boom, it gives me a lot of information. So let me go to the next slide so we can look at what information it gives me. Okay. So the first thing that I'm going to look for is the sample mean. And right here, X bar is the sample mean. It's a lowercase x. So it's 286.16. The sample standard deviation is 55.89, and I rounded. And my N is 30. So that gave me all the information I needed for right there. And now it says, which test should I use? I need to use a z-test because it's the population standard deviation was known. The next thing I need to do is state the distribution used for the hypotheses test. So remember, when we state distributions, we knew capital X bar, tilde, capital N, where the population mean, comma, population standard deviation over the square root of n. And all I did is I filled in those values. So here's population mean, population standard deviation over the square root of the sample size. Okay, the next part is find the p-value. Well, if you look here under p, I have the p-value. It's 0.1331. So I don't even really need to use the calculator anymore because I've gotten everything that I need from it. So at the preconceived level of significance, 0.025, what is your conclusion? Well, I'm going to look p versus my alpha. So 0.1331 is that greater than 0.25? Oops, let me do something right here. That one is, but look at that. Is 0.1331 greater than 0.025? It is that way. Where did I get this right here? I got this from the question. And if I go back to the question, it asks right here, this 2.05 level of significance. Because remember, I need to make it a decimal in order to be able to use it. So since my p-value is greater than my level of significance, because you can see that right here, I failed to reject the null hypothesis. Why? Again, p was larger than alpha. So what I can say is, because I failed to reject my null hypothesis, that means I'm keeping this hypothesis. I'm keeping where the mean equals 275. But I need to base it on my alternative. So at the 2.5 level of significance, there is not sufficient evidence to conclude that the true mean weight lifted was more than 275 pounds. Okay, since I failed to reject it, I need to still conclude based on not supporting the alternative. I don't know if that helps, but it might. Okay. All right, so let's go on. That was one with the data in the calculator. So let's look at one when you're not entering data in the calculator. Okay, so let me go back to this. Let me go back to the calculator. All right, so let's go back to ztest. So if I go here, things get interesting when I go over to stats because most of the numbers change. I get rid of the frequency in the list. What I actually get is this right here is population mean, population standard deviation, sample mean, sample size, and again, the sign that goes with my alternative. The output will be the same as before. I'll get my z-value, my p-value, my sample mean, and my sample size. So let's do an example. Jeffrey, as an 8-year-old, established a mean time of 16.43 seconds for swimming the 20-yard freestyle, with a standard deviation of 0.8 seconds. His dad, Frank, thought Jeffrey could swim faster using goggles. Frank bought Jeffrey a new pair of expensive goggles and timed Jeffrey for 25 freestyle swims. For the 15 swims, Jeffrey's mean time was 16 seconds. Frank thought that the goggles helped Jeffrey to swim faster than the 16.43 seconds. Conduct a hypothesis testing with the level of significance at 0.05. Assume that the swim times for the 25-yard freestyle are normal. Okay, so let's go ahead and let's see what we need to put into the calculator. Oops, let's go ahead and do some stuff first. Okay, is this a one mean or proportion? It's a one mean because it says average time. So what are my null and alternative hypotheses? Well, if the father thinks that the goggles can help him swim faster, that means he wants to decrease his time, not increase it. So my alternative is the mean is less than 16.43. So that means my null is mean equals 16.43. Is it a left-tailed, right-tailed, or two-tailed test? It's left-tailed because of that less than sign in the alternative. What symbol represents the random variable for this test? Again, it's capital X bar. In words, define the random variable for this test. The mean time to swim the 25-yard freestyle is what is represented by capital X bar. If there's a population standard deviation, what is it? Well, we know from the problem the population standard deviation is 0.8. It tells us in the problem, and that's how we know we can run a z-test, okay? All right, so from the problem, I got that the sample mean was 16 seconds because that's how he did for those 15 swims. And then my n is my 15. So what test can be used? Again, a z-test because the population standard deviation is known. So then I can do my distribution again. So X bar tilde n, where population mean, comma, population standard deviation over sample size. So I just plug that in. That's how you enter that and answer it. Okay, so the next thing, let's just put it in the calculator. So I'm going to go here. I'm going to turn it on, and then I'm going to put, okay, I'm going to do this. So then I've got some new stuff for this one. All right, so this one is going to be 16.43 because that's, 16.43. I don't know why it keeps doing that. Let's clear it out. 16.43. And then I'm going to go down. This is 0.8 because I got that from the problem too. So what is my sample mean? Remember that was 16, and then my sample size was 15. My alternative, this was a less than. So I'm going to hit that and enter. And that blinks. By it blinking, it shows that you've selected it. Hit calculate and then hit calculate. Okay, so I got a few things. I got my z-value, I've got my p-value, sample mean, and my sample size. Okay, so find your p-value. I got that, 0.01868, so I rounded up. At the preconceived level of significance of 0.05, what is your decision? Well, I just went ahead up here. I said P versus alpha. So 0.0187 is a lot less than 0.05. So that means because P is smaller than alpha, I have to reject my null. So if I reject my null, that means I'm keeping my alternative. So I can say at the 5% level of significance, we conclude that Jeffrey swims faster with the new goggles, or there's sufficient evidence to show that Jeffrey's mean time to swim the 25-yard freestyle is less than 16.43. That's all we did. We rejected the null, which meant we keep the alternative. So that is the two ways that you do the z-test in the calculator. I hope this has helped.